esteemed speakers, guests, and participants for our webinar on EV charging infrastructure and its grid integration in the Indian EV ecosystem, being organized by GIZ India and IIT Bombay. But before we start, some housekeeping rules that we are planning to follow. First is I would like to request all the participants to keep themselves on mute as well as off camera for the entire session. Though I would also request the participants to type your questions in the chat box, which would be taken up later in the Q&A session. And I feel it's my statutory responsibility to also inform you all that we will be keeping the webinar under recording. So in case anyone is unwilling to have the session or your inputs not being recorded, then please feel free to leave the session. So without any further ado, I would like to invite Miss Sahana, Junior Technical Expert at GIZ, to deliver her opening remarks. Sahana.
Thank you, Sushovan. Welcome everyone. Today's webinar is being organized by GIZ and IIT Bombay as a part of Transport and Climate Change Week 2021 of GIZ from 21st to 25th June. This is an annual event which is organized on behalf of the German Federal Ministry for the Environment, Nature Conservation and Nuclear Safety, the BMU. In 2021, it is taking place as a hybrid conference with a studio in Berlin with decentralized event locations in Asia, Africa, Europe, and Latin America. It is primarily aimed at transport policymakers and experts from our global partner countries and has the motto Smart and Green Recovery in the Transport Sector. The Nationally Determined Transport Initiative for Asia, NDCTIA, is a regional initiative funded by the International Climate Initiative, ICI, of the BMU. It is a joint project of 7 organizations and with the engagement of China, India, and Vietnam. For our project, our partners are WRI, ICCT, ITF, Agora Verkehrswende, REN21, and SLOCAT. Under NDCTIA India component, we have an ongoing project, Integration of Electric Vehicles Charging Infrastructure with Distribution Grid, the Global Review, India's Gap Analysis, and Way Forward. And this project is focused on conducting Indian and international review on overall environment related to EV charging. We are happy to say that this project is carried out by a consortium which is led by IIT Bombay along with Florence School of Regulation, Technical University Denmark, Cardiff University, and Universidad Pontificia Comillas. Under this project, we have covered some few topics, which are the fundamentals of electric vehicle charging technology and its grid integration, the global review and the status quo of electric vehicle charging infrastructure and grid integration in India, gap analysis and recommendations for EV integration in India. For this project, we have been undertaking stakeholder consultations and bilateral meetings where our findings are discussed with the stakeholders, and we also collect their insights, which will be duly incorporated in the reports. We aim to complete this project in the next 3 months and release a few reports from this project through webinars so that we can disseminate the crux of the reports. Few of the reports would be made available on public domain, whereas a few would be specifically curated for government stakeholders. The objective of today's webinar is to form a foundation and outline a few observations from the ongoing project on EV charging landscape and its grid integration in global as well as Indian scenario. We would also discuss the potential key directions for seamless adoption of EV charging in the Indian EV ecosystem. Now, let me take you all through today's webinar that we have. As you can see, today we have a 2-hour-long webinar with interesting sessions. We have the introductory sessions where we have the welcome address by Professor Rangan Banerjee, HOD Department of Science and Engineering in IIT Bombay. We have the keynote address from Mr. Madhav Sharma, Policy Consultant in Niti Aayog. In the presentation session, we have 4 wonderful presentations from eminent experts, Professor Pablo Frias from Comillas, Spain, Professor Quwei from DTU Denmark, Ms. Swetha Bagwat from FSR Global, Professor Zakir H from IIT Bombay, following which we will have a short Q&A session. And then we will move on to a panel discussion which will be moderated by Professor Zakir. And we have eminent speakers like Mr. Pankaj Batra, Mr. Avjesh Jha, Dr. Ganesh Das, Professor Pablo Frias, and Professor Martin Brown. Finally, we would conclude with a note of thanks by Dr. Indradeep Mitra. With this lineup of events, I wish you all a wonderful webinar today. And moving on, I would like to welcome and also request Professor Rangan Banerjee, HOD, Department of Energy Science and Engineering in IIT Bombay, to kindly deliver the welcome address. Thank you. Over to you, sir.
Thank you. Good morning. And it's my pleasure to welcome you on behalf of the Department of Energy Science and Engineering and the project team at IIT Bombay to this webinar. We all know that the energy sector is in significant transition, and transport is one of the important domains and the sectors where the entire transport sector is predominantly still dependent on oil and natural gas. And when we think in terms of this transition, we believe that transitions of these systems, these are socio-technical systems, have all kinds of implications. So we need to look at not just the vehicles, but we need to look at the charging infrastructure. And we are delighted to be associated with this project, because when we think in terms of looking at technologies, systems, and policies, it is important to learn from what has been done in other countries across the world. We are fortunate to have many partners who are sharing their experiences, and we've created a report where we've looked at, reviewed some of the experiences, the technologies, and we would like to present that to you, get your input so that we can create a document which can help understand and get some of the insights, some of the trade-offs which can enable this transition to be smooth. And whether it is two-wheelers, three-wheelers, four-wheelers, buses, the entire domain of transport, actually, when we think in terms of it, it's a question of investments. It's a question also of looking at making a renewable grid and seeing how the interface of these electric vehicles with the grids, can we have vehicle to grid? There are so many issues, and it's an opportunity for us to learn from what others have done across the world. We have reviewed some of this, and we have these documents. These will be presented to you in the seminar. We would like to get your inputs either during the webinar itself or even subsequently. So with this, I would like to welcome all of you to this webinar, and I would also like to request you to interact with our project team and give us input so that we can make something that is useful for the impending transition of the transport sector in India. Thank you.
Thank you, Professor. And we were excited as well to work with IIT Bombay. And thank you for beautifully explaining why we are undertaking this session and why this project was. And going forward, I would like to invite and welcome Mr. Madhav Sharma, who is a policy consultant at Niti Aayog, to provide the keynote address. Mr. Madhav.
Thank you. Yep. Thank you so much, and very warm greetings to everyone. And thank you so much for having me here. I'm really excited about
Mr. Madhav,
this. Yes.
Sorry to interrupt. Could you please come into the frame of the camera, because I think you will have to lower it. Yes, bit more.
Yeah. Is this better?
No, bit more. Bit more.
Yep.
Yes, better now. Please continue.
It's better?
Yes.
Hi. So a very warm greetings to everyone, and I'm really excited about this webinar on EV charging infrastructure and its grid integration in Indian EV ecosystem. My name is Madhav Sharma. I'm here representing Niti Aayog, where we are working on the NDC-TIA project along with the consortium of organizations. So let me start off by highlighting the need for creating and enabling EV ecosystem that not only focuses on adoption of EVs, but also its charging infrastructure. Availability of adequate charging infrastructure is the absolute key imperative for accelerating the adoption of EVs. You see, directly emulate the global best practices on the EV charging solutions, because it will simply not work. India has its own unique sets of requirements and challenges that unless they are solved, we won't be able to propagate the adoption of EV in India. Just last week, there was a report published by Grant Thornton, Bharat, and FICCI, where they had stated that we would need about 4 lakh charging stations to meet the requirement for the 2 million EVs that could be possibly be plying on the roads by 2026. There are also challenges, for instance, in the hilly areas where that would require more innovative charging approaches at home and workplace to address the dead mileage that depletes the energy. The government of India has really been proactive and has come out with a lot of initiatives and notifications in this regard. One such is the National Electric Mobility Mission Plan 2020, which seeks to enhance national energy security, mitigate adverse environmental impacts from road transport vehicles, and boost domestic manufacturing capabilities. In addition to this, as you all may be aware, the government of India has also notified the phase 2 of the FAME scheme to stimulate the market of EVs in the country, wherein we have delicensed the charging infrastructure business and specified guidelines and standards for charging infrastructure for EVs, and thereby opening up the market of public charging infrastructure. I'm a firm believer that an enabling government policy, along with the participation from the private sector and development of new technologies, have a key role to play here. And I'm very pleased to tell you that the NDC-TIA project, coordinated nationally by NITI Aayog and driven by a consortium of International Transport Forum, GIZ, REN21, WRI, ICCT, they have been proactively working towards setting up a charging infrastructure in ecosystem in India. Interestingly, one of the key deliverables that comes under this project is to do a study on rural charging infrastructure and make interventions based on that. The government is also working towards innovative low-cost charging infrastructure to accelerate the adoption of EVs. We are in the process of developing specification, prototype products, and undertake testing and validation of the Indian standards for low-cost AC charging point, where a target price of less than $50 has been set for a smart AC charge point operated with a smartphone. At the same time, there are going to be new innovations that would help devise effective and efficient strategies for the deployment of EV charging infrastructure across the country. An interesting alternative way of sourcing power is to use the roadways to transfer energy from power grids to EVs. And I'm sure we'll be learning more about this as we go through this webinar. This is something, and there's just like a growing interest in this concept of dynamic charging of vehicles on the move that alludes to the fears that EV batteries may run out in between the charging points. For that, we need to explore a complete suite of technology stack that includes design and development of not only the hardware, the charging hardware, but also the software side. We also need to explore maybe residential charging to install more than 3.5 megawatts of charging infrastructure in India. Meanwhile, as we enhance our solar power capabilities, vehicle to grid technology also offers in a lot of opportunity that can help in balancing the power grid by using EVs to drop power from the grid during peak generation, and we can store it in their battery when it's not running and transfer it back to the grid itself. So therefore, we not only need to create new pathways and infrastructure, but we also need to leverage the existing electricity infrastructure to be EV ready. NITI Aayog is actively involved in reviewing and providing feedback for reports from our ongoing NDCTIA project. One such report is the integration of electric vehicles charging infrastructure with the distribution grid, where we are doing a global review and we are looking at India's gaps and what could be the way forward. And with that, I would like to conclude my address. Thank you so much once again for having me here, and I look forward to listening to my fellow speakers.
Thank you, Mr. Madhav, for providing an overview on the Niti Aayog's take on electric mobility and beautifully summarizing the role of various stakeholders in this ecosystem. Thank you. And next, there is a series of 4 presentations that we would be presenting across. And you can put up your questions in the chat box. We would be taking up those questions later in the Q&A session. Feel free to put up your questions in the chat box provided. And next we have Professor Pablo Frias from IIT Comillas, Spain. He will be presenting on EV charging infrastructure and the global experience. Next, Mr. Pablo Frias, Professor Pablo Frias.
Good morning.
Good morning, sir.
Are you going to share the slides, or do you want me
yes,
to do
Professor.
it?
I will share I will project my screen, and I request you to kindly say next when you want the slides to be changed.
Yeah, appreciate.
Can you see my screen?
Yeah, right. Okay, so good morning. It's a pleasure for me to share with you today our initial work on global analysis for electric vehicle charging structure. Next, please. So basically, the idea of today is to go through first the categorization of the different charging infrastructures, and then we will go through the experience that we saw along the 4 main regions, UK, United States, Norway, and Germany. And finally, we will conclude this presentation with a brief comparison among all different countries and bring some ideas to be translated into India. Next, please. So in the next slide, basically we try to draw a picture in order to characterize in detail the different charging alternatives. Could we go to the next slide? So in this picture, you will see once it appears. Can we move to the next slide, please?
I have changed my slide. Is it not visible?
No, just the previous one. I think it takes a while to move from one to the other. So it's the previous one. Okay, anyway, yeah, fantastic. So here, the first work we try to do is basically to characterize in detail all the different charging alternatives. We have on the left of the picture is about the technical parameters, while on the half right of the picture is about regulations for business cases development. The technical definition is basically based, as you can imagine, on the energy, which is the kilowatt hour we need to charge the battery of the electric vehicle. That could be range from the 20 kilowatts hour that we have on a small car, for instance, on a Chevy, or we can move up to 100 kilowatts hour if we are thinking on a Tesla. This energy basically is obtained from the power times the time. Then the higher the charging power, the lower the time. That's something we all know. So we basically move from hours in slow charging, we move down to minutes in fast charging. Still a bit far away from the traditional refueling in a gas station. So basically here, the charging mode, which is the second column, defines all the other technical requirements. So basically, according to the standards, modes 1 and 2 refer to typical charging that we use for instance, for a household appliances, while mode 3 is specific for AC fast charging, and mode 4 goes to DC fast charging. So these modes 3 and 4 basically defines the charging speed and the different connectors types that you have also in the picture. The second relevant driver when addressing or when thinking about the charging infrastructure is regulation. So the first thing is whether we use this charging infrastructure for private use or for public use. Private is easy to understand. Public, then it becomes a lot of discussion because there are like different developers. For instance, it could be the energy utility, it could be the municipality, it could be the petrol company, it could be a car manufacturer, or even, let's say, an independent private company that wants to develop this charging infrastructure. Another really important point is how to access this product. It could be, let's say, contact. We put a contactor, or could be also contactless based on induction alternatives. And finally, that nowadays is, as we previously saw in the keynote, we basically, the e-mobility services are nowadays, let's say, moving ahead and are already, let's say, bringing into force. And in this case, for instance, the possibility of not being just a load as a vehicle, but also being a generator is something that could really change the thing. So next slide, please. So here, we also tried to bring, let's say, some real examples of basically the different connectors we see globally. Let's say that it really depends on the region where we are, let's say, thinking. For instance, in regions like, I would say the oldest one where we're, let's say, more developed was the CHAdeMO, which it's basically widespread in Japan for DC charging, and also is nowadays extended into China on the one side and also into the States and Europe. Sorry, still I cannot see the slide. Right, perfect. So here we have the CHAdeMO. You see on the right, and in Europe we have, let's say, a very standard approach, which is the MENECES. However, this is, let's say, the old way. Nowadays, let's say both European and American car makers has been trying to merge some standardization, and they move to what we call combined charging system, which is CCS. And here, this is, let's say, what we expect to be in near future a standard, but nowadays it is competing with the CHAdeMO. Anyway, when we think about the standards for connections, of course, in a country, it's a must to have a unique standard in order to make efficient moving around a country. And if we are thinking of regions, or let's say small regions like we have in Europe, or could be states altogether, we also have to have some standardized. However, from if we are thinking on a worldwide, as we do for household connectors for appliances, there is no practical mandatory need to have, let's say, one single standard all over the world. However, from an efficient manufacturing point of view, yes, it will really improve the thing. Next slide, please. So it is clear that when we are thinking about the charging infrastructure, first we need, it's what we call the chicken and egg problem. So first we need the chicken, who comes first, chicken and egg. So here, who comes first, electric vehicles or charging infrastructure? In this case, If we check the evolution of electric vehicle sales in the recent, let's say, decade, we can see that it's following a clear exponential approach, mostly because in the last decade, because of China pushing very hard on that, boosting, because of, let's say, very, very good incentives. Nowadays, they cut down the incentives, and it was last year, Europe, let's say, pushing ahead the sales of vehicles. Of course, being China the leader, if we think about the charger, of course, most chargers are basically located in this country, whether they are private or. Next slide, please. So when we think about the private chargers are not only the ones that we can find, let's say, at home, but also the ones that we can find, let's say, in the office when we get to the office, and that are, let's say, basically in the building. So if we think about this definition of private charging, we realize that the ratio we have, let's say, all over the world is 1.1, which means 1.1 chargers per vehicle. So there are, let's say, more private chargers than vehicles. That's why we have this double counting. On the other side, if we go to China or Japan, this is not the case. So next slide, please. The next one, please, because that's the one on the charging. So now the idea is to focus on the four.
I have moved it, Professor.
Sorry? Yeah, next slide, which is the one on the UK EV market. Okay, so now basically we'll try to focus on the four international countries we consider in the analysis. First, we will look into the UK, where basically what happened in the UK is in the first, we take a decade. In the first year, it was the plug-in hybrid electric vehicles, the one pushing ahead. Then in the recent 2 years, it was boosting the battery electric vehicles. So nowadays, battery electric vehicles are the ones that are, let's say, taking the lead in the sales. If we check which let's say types of cars are sold, basically we think about luxury cars, like we have Tesla or we have BMW cars. This has a direct correlation with the private charging and with the public charging infrastructure. That means that, of course, the more, let's say, luxury cars you have, of course, maybe more private or more specific, in this case for Tesla, charges we will face. Next slide, please.
Professor, I believe there is some challenge in presenting. Let me present the slide. Please give me 1 second.
Yeah, sure.
Are these slides visible?
Yeah, perfect. So next slide. Next one.
Are we here?
Right, perfect. So we are on it. So here we can see that, again, in the UK, we realize that the battery charging electric vehicles are the one that nowadays are predominant. So that's why, let's say, really important. These cars, the best sellers today in the UK, they require, let's say, fast charging. So in this case, you can see that most of the charging that nowadays is developed there, more than 50% of that is over 7 kilowatts. So that means like public charging is really evolving that way. Next slide, please. Okay, so if we go to the States, we have a similar trend that we face that we saw in the UK, basically with a big push in the last 2 years. Again, in the case of the States, you know, Tesla is the car maker, is an American car maker, so that's why most of the cars, the bestseller cars, are the Tesla Model 3, Model S, or Model X. We have some, let's say, more popular cars in the middle, but that's the main topic. And this is let's say, a critical thing for the charging. So next slide. So here in the figure on the left, we see that the most common public chargers are what we call the J1772, which is level 2, which is, let's say, a traditional, it's similar to Meneke, so it's the traditional AC charging. But it is also really important that Tesla charging strategy, let's say, covers 20% of the public charging poles, which is, let's say, it's a lot, but that's the reason why, let's say, you have more cars. That's the problem of the chicken and the egg in the inverse way. So the similar results you can see on the picture on the right. Next slide, please. So in Europe, things are a bit different. Here we present the case of Norway. Norway is the country where last year more than 50% of the sales, of the global sales of new cars in 2020 were electric vehicles. So that means that, let's say, they are moving very fast on sales of electric vehicles. And in that way, we also see that most of the charging, the charging strategy is already developed. We see that here 50% of type 2 is a bit lower compared to the 70% we found in the UK. And also here we also see the effect of Tesla. Tesla in the US was 20%, while here is just 6%. In Germany, it is also a very important example because in this case, it is not because of Norway, mostly driven by the incentives. They don't have, let's say, car makers at home, but in Germany, you know that the car industry is really strong. So the car industry, together with the government, really push for charging stations. And you can see here in this picture that there is a big effort in creating fast charging system, which is the 78%. Mostly of that is CCS. That means that, let's say, we are really moving ahead or preparing the system for a fast adoption of electromobility. And that's really good news. Next slide, please. So now trying to summarize all the ecosystem of chargers. If we compare the 5 countries, of course, if we look into the absolute numbers, US is nowadays leading. You can see that in the figure in the top left. But also it is interesting that the most common chargers are fast, which means that it's really some, let's say, playground prepared for the EV adoption. And the second option is not slow charging, but let's say very fast or rapid charging. That again is something that is really good for the system in this case. Next slide, please. So now, if instead of, let's say, taking a look to the absolute numbers, we go down to the relative numbers, we see some differences in Norway, which are relevant, where the number of electric vehicles per, let's say, charger has increased a lot in the recent years. However, they increase faster than the building of charging stations, which, it's something that is what we will go, let's say, it's a way of seeing a maturity in the system, while in the other regions is charging stations which are moving ahead of electric vehicle sales thanks to governmental support. So this is a very important also analysis to consider, and that is you can take in the report. Next slide, please. So to conclude here, we bring some, let's say, unique examples of how we can manage the charging poles using original ideas, like, for instance, retrofitted lamps to create that, or curved sites for the connection. We have the traditional, let's say, contact approaches with the pantograph on the top, and also on the ground. Still, these two approaches, this approach of the pantograph on the ground has some safety, let's say, needs and requirements, and still they have high investment costs. And we also have, let's say, contactless or induction systems, still also expensive options. However, I mean, they are nowadays on research, so for sure in the coming years, we will expect something on that. Next slide, please. So basically, to conclude, the first important thing is that there are two main actors that are, let's say, driving the evolution of electric vehicles and charging stations. One is the technical standardization of conductors for the industry. Of course, I mean, inadequate policies to really incentivize sustainable mobility, to eliminate what we call the range anxiety problem. So these two things should be together. Then policy should promote efficient charging infrastructure development, so sending specific economic signals to all the possible actors. This is not, when we think about public charging, this is not to give money for the municipalities to develop the infrastructure. It is to create markets for that. So we need to be efficient on that. It is the car makers, it is the utilities, it is the energy companies, it is the traditional, let's say, gas station companies. We need to incentivize these in an efficient way. Fast chargers today are dominant. That's good, which is a fantastic opportunity for EV promotion. Second thing is super fast chargers are increasing nowadays. Here we have, let's say, basically a competition, or let's say something together with the CCS approach, which is the combined charging system together with the CHAdeMO. Both of them will increase in the coming years. Very important from the cases we check. Norway is a good example of EV promotion, but of course we need to encompass this EV promotion to be, let's say, more or less in line with the public charging system in order to move ahead. Other European countries, not the ones that we saw here, but others nowadays, let's say, are moving slowly in the public charging because still the EV numbers are still very low. So still there is a need for standardization, but not only on what we present here today, which was basically focused on the electrical connection, but it is also very important to think about the e-mobility services that will require for this connectivity, not just amperes, but we also need to connect the megabytes for connections in order to provide additional e-mobility services. So all the analysis that we in summary presented here are written in the report that we will share with you, I guess, in the coming days, and we will be really glad to have an open discussion on this. Thank you.
Sure. Thank you, Professor Pablo. Thank you for providing an overview on the global charging infrastructure types and how the EV charging infra market is being driven internationally. Thank you so much. Again, I would like to inform the participants that feel free to put up your questions in the chat box of the webinar. We would take up the questions in the end in the Q&A session. Next, I would like to invite Professor Quwei from DTU Denmark to provide to present us on international experience on EV integration. Professor Quwei.
Okay, yeah. Yes, good morning, everyone. And it's a great pleasure to be here to give a short introduction of our work on the status of EV integrations. Yes, please put up the slides, please. Next. Yes, and actually we have done quite a comprehensive review of the EV integration status of the world, and because of the time limit, I will just give a few examples in the UK, Germany, Norway, and the US and Denmark. And yeah, there are a lot more details in the report. If you are interested in the details, please refer to the report. And so next one. So first I will start with the case in UK. So in the UK, the distributed system operator have placed a very active role in the EV integration. They will, for all the new EV charger installed, they have to get approval from the distributed system operator, and also the system operator has to get an overview of the system status and also try to see how much capacity is available for the new chargers, and also depending on the EV integration levels, the upgrade or reinforcement of the grid infrastructure has to be assessed, and also the upgrade should be in place if there's a need for that. Next slide, please. And now I'd like to talk a little bit about the EV integration status in Germany, and specifically for Berlin. And so for all the new users with the EV chargers, they have to get approval from the system operator, and also they also have to whenever they have the charger installed, they have to comply with the regulatory requirements, and also please go to the next slide. Yeah, please move a bit, and yes, could you please also move forward? Yes, yeah, and also regarding the charging modes, that there are four types of charging modes, and the first one is the very basic charging mode. So all the users will just charge their electric vehicles based on their needs, and there's no coordination. So it's kind of plug and charge, and it's also called dumb charging. And the second one is a static charging management, and so the available charging capacity or margin is shared with among all the charging points. The third one is the active charging management. So it's a bit more advanced than the static charge management. So the available charging capacity is distributed among all the charging points proportional to their charging capacity, so it's a little bit more advanced. And the last one is the dynamic charging management. So it's not just about the capacity, and also the grid operating status will be taken into account when the charging schedule is determined. So like the status of the transformer and also the loading of transmission cables. So the grid status will be considered in the dynamic charging management. Next slide, please. And in Norway, actually Norway, it's leading the EV deployment over the world, especially regarding the number of EVs sold every year, and also the percentage of electric vehicles in the whole transport sector. But even with the fast deployment of electric vehicles, we can see that the energy used by the electric vehicles is still not very significant. It's for the current we don't have the latest number, but if we look at the number in 2017, that only the percentage of electricity consumed by electric vehicles only had a very small percentage. It's about 0.14%, and even with all the personal or passenger cars are changed to electric vehicles, we can see that the electricity consumed, it's still only a small portion of the total energy demand, but it has a very big impact on the local distribution systems. And if every household has about 1 to 2 kilowatts capacity increase or the demand increase, then most of the transformers will be overloaded. So this is the kind of challenge we have to deal with if we have large-scale deployment electric vehicles in Norway or in other countries. That I suppose this is a prevailing issue in most of the countries. Next slide, please. And in the USA, they have this time-based tariffs for EV charging. I mean, this kind of time-based tariff is not designed for the electric vehicle charging or EV charging, but they have it mostly for the demand response and also the peak load shaving and also demand shifting in order to reduce the peak load and try to avoid overloading issues or maybe and also voltage issues in the distribution systems and also from the overall system perspective. But this time-based tariffs is also quite useful for the EV charging because if we can imagine that if all the electric vehicles are charged at the same time, there will be a very huge peak demand. So the time-based charging could help a little bit to alleviate or mitigate the impact of electric vehicles on the system operation. And there are two types of time-based tariffs. The first one is based on the net electric demand, so it doesn't differentiate the conventional demand or other demand and the EV demand. So this type of time-based tariff is beneficial or good for the customers who has small storage, so it can try to balance or try to shift the EV charging demand to the lower price period. Then it's better. It's the economic benefit for the customer is bigger. And the second type of time-based tariff is based on different metering of the other demand and EV demand. Then it's good for the customers who has intelligent management of EV charging, and because it's treated separately. Next slide, please. And also we covered the power quality issues regarding the EV charging, because the EV charging could be done by one phase and also three phase. We also checked the power quality issues. This work was not done by us, but it's kind of review of the existing work related to the power quality issues with the EV charging. And here it's the results reviewed regarding the single phase charging. And the figures here is try to show the current and also the distortion, total harmonic distortion at the beginning of the charging cycle, and also a bit or more to the end of the charging cycle. And from the figure, we could see that at the beginning of the charging, the THD is quite low. I mean, it's quite concentrated on the nominal frequency, but and also when it's approaching to the end of charging cycle, we can see that the THD, I mean, the harmonics are more distributed, and also the percentage of the harmonics are higher. I mean, it's kind of for sure that when it's to the end of charging cycle, the THD is higher, but actually this results are a bit misleading, because at the end of the charging cycle, the current is charging current is lower. So that's why the percentage of the THD is higher, but actually the magnitude is not so big. So so we can say that the power quality issue is not so significant. And next slide, please. And here we showed, we used the results from other researchers regarding the three-phase charging and also the impact, the power quality issues. And we have similar results compared to the single-phase charging situation. And so at the beginning of the charging cycle, the THD is quite low, especially the percentage, and to the end of the charging cycle, we can see there are quite some distortions in the current, and also the THD is higher. But again, the charging current is lower when it's approaching the end of the charging cycle. So the overall THD, it's not, especially if we check the magnitude, it's not so significant. Next slide, please. And now I'd like to talk a bit about the situation in Netherlands, and they have published the critical requirements for the vehicle-to-grid. I mean, vehicle-to-grid is about the service from the electric vehicles, and also some requirements for the EV charging. And so all the electric vehicles has a vehicle-to-grid capability. They have to register their location, and also the unbalanced charging is not allowed in Netherlands. And they have some requirements regarding the service from the electric vehicles, especially for the frequency and also voltage control. On the right-hand side of the figure, just to show that it's kind of requirements when the system frequency is changing or has some significant deviations. The electric vehicle should be kind of connected and act as resources, just like other generation units, to stay connected and also provide the frequency control services. And also, yeah, there are some specific requirements regarding the communication. They have to provide all the data, especially for the location and also charging situations to the system operators. Next slide, please. Next slides. Yes. And also in Denmark, there was some critical requirements for the electric vehicles. It's not specifically designed for the electric vehicles, but it's more about the distributed energy resources. And so here the numbers are just indicative, because they are treated as distributed energy resources. And so we can see that with different capacity, the requirements are different. They're put into 5 categories depending on the charging power or the capacity, and there are different requirements for the system operation or the service requirements from the charging facility or the electric vehicle, depending on the capacity. And the services required are mainly related to the frequency control and the voltage control, and also some ramp limits. So we can see with smaller capacity, the requirements are less, and if the capacity is quite big, especially for the large charging facility, it has to provide all the requirements for the frequency control and the voltage control. And the next slide, please.
Professor Quwei, sorry to interrupt. In the interest of time, it would be nice if we could wrap up.
Yeah, sure. Yeah. Okay, I will try to conclude. Yeah, and yes, and also, yeah, we have done quite a lot of demonstration of the EV integration, and especially in the here are some summary of the barriers for the vehicle-to-grid service in Denmark. I'm not going to going into all details and due to the time limit. But it's mainly the economic barriers, whether the customer have enough economic incentives and also technological barriers, especially regarding the capability of the electric vehicles, and the social barriers about the awareness of customers and also the subsidy from the government. Next slide, please. Yes, we have this PAC project to demonstrate the frequency control service from the electric vehicle, especially based on the aggregated concept. And it's the consortium, including the technology providers for the charging infrastructure and also the aggregate concept or the aggregator software to manage the intelligent electric vehicles for intelligent management for electric charging, and also to demonstrate that it's quite economic to provide the frequency control service. And next slide, please. Here are some results we have obtained to try to show you that we can manage to provide the frequency regulation service based on the aggregated concept, and also especially with the communication with the electric vehicles, and also we can see we have on the left hand side at the bottom we can see there's more delay about the regulation required and also provided, but still the performance is quite satisfactory. And next slide, please. Yes, so we in the presentation I tried to give an overview of the EV integration status in different countries, and we can see that the system operator has an active role in the EV integration, especially to specify the grid connection requirements and also the service requirements from the electric vehicles, and also we can see that electric vehicles has a big impact on the local distribution systems. We have to come up some mechanisms to deal with the quite big demand from electric EV charging, and also it has been demonstrated that electric vehicles could provide the system service, especially the ancillary service based on the aggregated concept and also the communication capability. Yeah, that's it. Thank you very much.
Thank you, Professor Quwei. Thank you for providing an overview of the V2G aspects of charging infrastructure and the EV ecosystem. Thank you so much. Next, I would like to welcome Ms. Swetha Bagwat from FSR Global Florence School of Regulations to provide an overview on the EV policy regulations and charging infrastructure in India. Over to you. Over to you, Ms. Swetha. You are muted, I believe.
Thank you, Sushil. Let me quickly just share my slides. Can you see my screen?
Yes,
it's
Swetha, we can.
I'm just making it into presenter mode. Perfect. Firstly, thank you so much for GIZ for giving us this opportunity to present preliminary findings or research work. So what I will do is follow suit of what Pablo and Quwei presented and sort of dive deep into the of policies and regulation via my next 10 minutes of the presentation. So what I'll be presenting is, of course, just a sneak peek into where we stand. We won't be able to do justice by covering all the aspects of the policy and regulation within India, but intend to give you a quick preview into what's been going behind the scenes. So our agenda is pretty clear. We'll just run through some of the key policy initiatives in India that are shaping why we are here today and why we're discussing this topic particularly, as also the speaker from NITI Aayog did clearly state. And then we will give you a quick overview of some of the state policies and where they stand and how diverse is one state from the other, and some notable regulatory guidelines, particularly from other cross-cutting aspects that would directly or indirectly impact the EV landscape. So that would be the order of the presentation in my set. So I'm not going to go through all these details. What EV is not something very new for India. Over the last decade, literally, we have been discussing this topic, and the government has been playing a proactive role in trying to set up the minimum requirements or the ingredients to sort of initiate the EV sector in India. Of course, there is a lot of trial and error process in setting up a big major policy initiative such as this. And given the complexity of India, where we have a central and state coordination to keep in mind while at electric vehicles, because it's part of the, it falls under the power sector, also to the mobility sector. So it's not only complex in the business as usual scenario, it makes it even more complex because we have different overlapping sectors that need to be accounted for. But what you can clearly see is that there have been a lot of steps taken since a decade, and there has been revisions and feedback taken in, and which is an indicator that the policymakers are quite aware of what they're doing, and they would like to sort of shape the ecosystem in a way that's beneficial to the country. So that's a snapshot of where we stand last decade. Well, of course, in terms of the decision process, given the complexity of India, those are not just deal with, but we also have different layers of deal with. This is a snapshot of the key stakeholders, but a map which is here will give you a bit more details on some of the micro actors that would influence the different processes of decision making with the electric vehicle policy making cycles. So what's interesting to see is, of course, whoever is in charge, it's not an easy task at all for them. They need to coordinate with so many different stakeholders, understand their requirements, and then loop all that back into the regulatory and policy decision making. So, of course, it's a mammoth task, and hence it's a trial and error basis that's been happening. But something that's very clear is the need for not working in silos, but to be having a much more stronger coordination between of decision makers. So we need the power sector, the Ministry of Power, the regulators from there to interact, say somebody from the housing, somebody from the mobility side, and all the different players across the value chain of the development of the EV ecosystem, right from car manufacturers to the charging infrastructure, to the power utility companies, all need to be on board to make this sort of a success. So there is a lot of experiments and pilot projects that are happening, but definitely we are sort of gaining sort of how to cook this dish, if I were to use that. So where it all started.
Sorry to interrupt. The slides are not changing. Maybe someone else can share the slides.
If I cut off my video, would that help? To save on
that might help.
Bandwidth? Yes. Which slide can you see right now?
The NEMMP slide 6.
Yeah. Yes, perfect. So I'm on. Okay, I'm on. Okay, perfect. So let me know if there's a lag again. Okay, sure. So I think the clear the journey of the EV policy started when India with this NEMMP policy framework, which was instituted. Of course, if you look at the key parameters that have been considered within this framework, we see that the policymakers wanted to develop the entire ecosystem of EVs. So right from the adoption of EVs to the consumer acceptance, to the vehicle, the chicken or the egg problem that Pablo did mention quite strongly, and also looking at strengthening our manufacturing segment of EVs. And complementing this were two other series of I would like to request those who are not speaking to kindly mute your microphones, because it's disturbing with the speakers. Thank you. Okay. So yes, the other set of policies that have been influencing have been the FAME 1 and 2. Why I would like to present this slide is to draw upon the change in the focus of the policy One, there was more focus on sort of helping in the technological development and trying to come up with some pilot projects. But moving on to the second phase, what's been the primary focus is on giving more on demand incentives. You can see the significant chunk of all the money that's allocated is going to that. But what's important to note is that there is very little money allocated for charging infrastructure. So again, here we have a bit of a dilemma on what comes first. But of course, we will see that most of the state policies have used this demand incentive allocation in sort of across the different kinds of vehicular categories. But there is still a need to sort of beef up on the charging infrastructure aspect. That's been a drastic change in terms of the phase 1 to phase 2 of the. Now, we do have one Government of India guidelines, but of course each state is free to adopt and amend that to suit the needs of their local EV ecosystem. So most of the states have done that. Of course, as you can see that not all states would just sort of cut, copy, paste the guidelines. Each of them have adapted and tuned it to their local needs, which means it's not uniform across all states. So this this diagram here just presents where is the status quo of the various states within India. As you can see, there is a significant chunk of the country which has issued a final EV policy, whereas other states, some major ones as well, are in the process of a draft version. And some remote pockets still not yet caught on to the EV bandwagon, but of course they also come from very different terrains, which probably is not yet EV conducive at the moment at where the technology stands. But as you can see, pretty much the entire central and north part of the country has caught on to the EV mobility requirement and is proactively making these frameworks. And if you look at the timeline, you see that most of the policies have come in the last couple of years, with some of them being very recent in the last couple of months even. So there has been a lot of traction at the state EV policy making, especially in the last 2 years. And I think this has been instrumental, COVID or not. I think the states are still moving forward with this requirement because the overarching reason of why we are doing this is dictated differently in different parts of the country. So I'm just going to give you a quick snapshot of what's happening in one of the key states, which is also a city state. So it's a very unique policy making opportunity, and also as a business case to study, because the Delhi state is also a national capital region, which overlaps with the different neighboring states, and is also one of the places where the infrastructure is quite robust. So if you look at the key snapshots of what the Delhi state policy covers, it does have a significant amount to kickstart the EV ecosystem, which by providing a lot of incentives for similar types. So they have different kinds of incentives for different kinds of vehicles. Of course, also cross-referencing, taking away subsidies from ICE vehicles. But we also see that there is funding or policy guidelines on the charging infrastructure, and here we see it has forging, setting up of charging stations, and also particularly mentioning battery swapping. So these are the specifications in terms of charging infrastructure. But what is notable in the Delhi aspect, which is unique and not yet picked on by many other states, the attributes which help in the evolution or the development of different business cases, say if private players were to come in, and if India were to move from the initial state of development to the growth stage where there is much more competition in the sector. So the specific attribute in the case of Delhi is to open up different payment methods, which is very important from a business case or a business model perspective. And also the most important is providing real-time information on EV charging details, and it goes into the length of giving us the location, the type of charging available, the availability of the charging infrastructure from a consumer perspective, and also the pricing. So I think these two attributes would help different players to come in and offer different innovative business schemes, which would sort of also tap into the consumers to sort of come in and adopt into the EV vehicular segment. So this is something that's notable in the case of Delhi. But okay, I'm sorry, this slide will come later. Oh. Okay, I see some slides are missing, but okay. The most important aspect that I would like to say when we look at the different states of EV is that still a lot of the policy focuses more on the demand side, where we are looking at encouraging EV mobility, but there is still less focus on setting up on the supply side, or that's also setting up a charging infrastructure. Particularly, policies are still to mature in terms of unlocking the future potential of EVs. And I think Quwei did mention about how we need to incorporate futuristic things such as dynamic tariffs, something that is that may be applicable to India, but a lot needs to be still looked into whether or not how we can make that happen in the case of India, particularly looking at the different consumer segments that we have in India. Because we cannot just cut copy paste from the West. We need to sort of also look at how it is applicable in the terms of the Indian consumer brackets that these different mobility segments would try to target. So that is something we need to sort of keep in mind. A couple of notable policy and regulatory mentions that we have, of course, 19, we have two significant contributions from in terms of the technical standard. Why important is because sort of help give direction on how the charging in itself would sort of pan out in the case of India. And I think the two notable ones is in the beginning we had more technical standards, and second, in the amendment in June, we see that there's a lot more safety measures being incorporated, and a lot of emphasis on sort of strengthening the last mile connectivity, and particularly a lot on this companies.
Hi Swetha, due to time constraints, can we just speed up?
Strengthen. I cannot hear you. Yeah.
I'm saying due to time constraints, can we just speed up?
Just a minute, and then I should be able to quickly go. Yeah. Then the other notable one is, of course, the charging infrastructure itself, which a notable mention is, of course, including also battery swapping, whereas previously it was just looking at providing charging stations. That's been a significant change in charging infrastructure. And another thing, policy that does influence vehicles is on building regulation. I'm not going to go into specifics. You can have related to details. What's important is that we have a proactive policy that includes EV charging station as a mandated in buildings that are coming up in the future. And I think that already sorts of the tone for the future. Last but not the least, we have the EV tariff landscape, and as I was mentioning, it's not uniform across all parts of the country, which sort of helps gives challenges in terms of business models and interoperability from the consumer standpoint. But nonetheless, it's a direction much more advanced than what we had 2 years ago, where a lot more specific EV tariffs have been issued, and also there are some more challenges in switching from the usual tariff that we have to a more dynamic tariff, because as I mentioned before, the different kinds of consumers, probably the consumers who would benefit most would be one who would not need it, whereas those who need it are not the ones who can afford it. So there are a lot of social economic challenges that need to be incorporated, and of course also the development of smart meters would be critical sort of materialize in the future. So in conclusion, some of the key observations that we've had so far, this is also work in progress. Just to hit upon the efforts, as I said, can you see my last slide now?
Yes.
Perfect, that's the last one. Okay, so just to sort of sum it up, the key drawback or where there is more work to be done is on how to support the charging infrastructure development, because if that's not conducive for a consumer or for various types of consumer, probably there wouldn't be enough incentive for individuals to go and pick on electric vehicles, because most of the Indian metropolitans are quite large and the distances are a lot to cover. So we need to sort of pick up on our policy and beef up our charging infrastructure side of the policy. Grid upgradations are, of course, required across. This needs to be factored in. Particularly, we need to also look at the high tension lines, and discoms will have to play a much more active role, and this role of the distribution companies need to be a bit more actively discussed. And given that the state of the distribution companies need to also see how this additional burden would sort of add to their business case. incorporated. Regularity is something that we need to factor in. I think one of the only states that does look at it is, I think, Andhra Pradesh, but much more states need to look at allocation of land for setting up of charging infrastructure. Swapping stations have, as I said, battery swapping has been included, and we see that there have been a couple of revisions in the policy in terms of how to accommodate that from a business case point. And also, there is a lot more emphasis on how to consider different kinds of charging stations for the four-wheeler segments. And as I mentioned last, I think if we need to have interoperability and other things, we need to also have a robust platform which helps exchange of information. But from a consumer standpoint, we also need to have a single window clearances for those who want to set up business and those who also have in terms of grievances that need to be cleared. So I think a more unified and a structured way of helping businesses set up charging infrastructure would be helpful in terms of realizing all these policies into reality. So with that, I would like to pass on the floor back to GIZ, and in the next presentation, you will see some more analysis on what's lacking and what needs to be done. Thank you.
Sure. Thank you, Ms. Swetha, for presenting an overview of the policy and regulatory landscape for the electric mobility ecosystem across India, and also for providing the snapshots of the EV policies of few of the states. Next, I would like to invite Professor Zakir H from IIT-Bombay to present us on EV integration and gap analysis in the Indian EV ecosystem. The floor is for you, Professor Zakir.
Thank you, Shravan, for your kind introduction. Please just let me know if you can see the slides in presentation mode.
Yes, visible.
Great. A very good morning to all the participants. So these presentations that you have been seeing from the start of the session are connected, and there are some of the aspects that you would see very well connected with the previous three presentations. But as the title says, the focus is on the gap analysis in EV this charging infrastructure in India, and it is grid integration. So we'll directly jump to the contents here. So you can see we have been progressing on adopting EVs, and there has been initial push for more these two-wheelers and three-wheelers, and if you can see here, the numbers are higher for two-wheelers and three-wheelers here, and there is an increasing trend in uptake of the four-wheelers, and down the line we're expecting that four-wheelers are going to be also share a reasonable market in the EV segment. Coming to the charging infrastructure side, we are predominantly, as has been highlighted in the earlier presentation, also predominantly slow charging infrastructure based country as of today. And if you can see here from the plots, we have this total public chargers roughly around 1850 as of 2020, 2021 as well. You can see here the figures, and slow chargers are actually dominating. As you can see the numbers here, fast chargers as per our category are really less in the number, which shows that looking at the international trend and the requirement for public charging, we need more focus on the fast charging when it comes to public charging space. Having said that, we have some of the aspects that are already taken up in terms of this charging infrastructure in India. FAME 2 has focus on the charging infrastructure. There's a fund allocation for charging infrastructure in India. We'll talk more about that. Different players have been putting up the charging stations in different cities, and private players are also coming up in this space. And we are hoping down the line that there is going to be more participation of the private players, and the market is going to be competitive, and the business models are going to be more and more sustainable in the charging infrastructure as we move forward in this EV journey in India. So if we look at some of the gaps in the charging infrastructure in India, one of the issue is this adequate support for private sectors who are in the business of, or who can potentially be actually in the business of this charging infrastructure development. For example, one of the issue as of now for private players is grid infrastructure upgradation. If they're putting large charging station, high power charging station, or fast charging stations, they are most likely going to have this requirement of the transformer for connecting it to HT. And as of today, it is these charging station CPOs who are supposed to bear the cost. That is a very significant discouraging factor for them to come in the market of this charging infrastructure. There is, this misalignment that we saw, in our opinion, between subsidy in charging infrastructure and vehicle subsidy. If you look at the segment side, subsidy in frame at central policy level, central government policy level, is more towards two-wheeler, three-wheeler, while as charging infrastructure subsidy is towards four-wheeler charging infrastructure. Having said that, four-wheeler charging infrastructure does not cater as such directly to the two-wheeler charging needs because of the compliance and compatibility issues. There is also what we noticed is lack of alignment between charging demand and allocation of charging infrastructure. For example, under frame 2, this the number of chargers that have been actually allotted to different states through different agencies, government agencies, we noticed that there is a misalignment. There's a misalignment between number of charging stations allocated to ST and actual growth of EVs in ST. For example, Delhi has around 3,000 these four-wheelers, and they have been allocated around 72 charging stations under frame 2. Chandigarh has around 100 EVs, so these four-wheelers, and they have been also allocated around 70 charging stations. So there could have been and could be down the line more alignment of this allocation of this charging stations depending on the EV growth in a given city. No subsidy for battery swapping. I think we'll talk more about it in one of the slides. I already talked about the grid infrastructure. And some of the other issues that we have noticed is initial push has been, as far as the four-wheeler segment is concerned, has been for primarily for this AC001 and DC001 charging infrastructure. However, that most of these two-wheeler, three-wheelers, and four-wheelers are not compatible with these charging stations. So therefore, that is something we noticed, we observed is an issue in the charging infrastructure in Indian EV ecosystem. Slow chargers, need for slow chargers is also very important for this issue with the public charging, where people, those who want to utilize this public charging space, are not going to have time to wait in queue for long to get their vehicle charged. So therefore, there is a need for fast charging in public charging space, but at the same time, there are other issues which need to be addressed before we advocate only fast charging for public charging stations. As the picture shows, that there is unorganized discharging infrastructure, particularly for three-wheelers, that needs to be more organized. The additional challenges that we have observed is there is what in terms of this charging infrastructure market in India. Of course, there is EVs, number of EVs have to actually grow for this, as some of the speakers mentioned, the chicken and egg problem, which some of the experts do not agree now as of today. But still, these are dependent on each other, so that is also one factor: low number of EVs in the country. Grid upgradation, which I already mentioned, I will not repeat it. So is an issue, as it's an open kind of issue, which as of now is primarily left to the CPOs who want to develop these charging stations. Land availability is the other issue for this charging infrastructure. What we noticed is under FAME 2, these charging stations which have been given to different government agencies or PSUs, what they have been doing is depending on their availability of the land in their offices or some other infrastructure establishments, they put up the charging stations in those locations. But at the same time, there is a need to align the location of the charging station and the demand of the charging station. So if it is not in the city where the charging stations would be actually more utilized, and if it is in a space in the office space which is actually not connected to the charging to the city where EVs are going to be moving, there is the misalignment of this optimal location of these charging stations. Land availability for private chargers is a significant issue as of now. That also needs to be addressed in terms of how they can be made land available easily through different sustainable market rules or models or these business models between different let's say government agencies who have this land available in a city and these private players who would be interested in putting up the charging infrastructure. Standardization of charging infrastructure for two-wheeler, three-wheeler, it is still open in India. There might be, I would say, has to be a balanced approach here in standardization, but it still needs to be standardized. It is as of now primarily, proprietary-based chargers for different two-wheelers depending on the manufacturer or the maker of the two-wheeler. Other challenges is the distribution system that we have in some of the states. I would say majority of the distribution systems, apart from some of the distribution system networks, there is less margin available to accommodate more this charging load, and that is something which need to be taken into consideration while devising more constructive policies and regulatory enablers for seamless adoption of the charging infrastructure in Indian system. This DISCOM weak financial condition is always an issue, going to be an issue which needs to be addressed. And this grid upgradation, this is a kind of open issue as of now. Who should actually go to this? Who should pay for this grid upgradation? If you look from the distribution system operator, they can, depending on how you see it, they can also not actually put up the upgradation cost because of their other constraints, financial constraints. Then CPOs have their own issues this is going to be quite detrimental for their business opportunity in the charging space. So there is a need to address this issue. There is a need for subsidy allocation for the subsidy as of now is in FAME 2, under FAME 2 is primarily for the EVSC. There is no subsidy for grid upgradation. Probably there needs to be a reasonable focus on incentivizing or supporting grid upgradation. Then only we could actually have this uptake of these fast charging stations and large charging infrastructure in the grid. So this issue needs to be addressed, in our opinion, at a priority level. EV tariffs, one is transparency, and there is also harmonization of EV tariffs across the states that needs to be taken into account while devising these EV tariffs for EV charging in different states in India. Regulation side, of course, there are commercial regulations in place. Every state has, most of the states have their commercial regulation tariffs and all. Technical regulation, on technical regulation front, there is hardly any actually development as of now, which might be attributed to different factors, but considering the growth of the EVs that we foresee down the line, there is a need to look at the regulations or technical regulations of integrating this EV charging infrastructure, which is important. I would say balanced regulation, because the other side of the stakeholders, CPOs, may think that regulations will kill their, will affect their business. But if you look from the distribution side or the grid side, there is a need for regulation, which we have learned a lot from the renewable energy integration. So there is a need for balanced regulations that need to be taken into account considering the future development in the charging infrastructure in India. Smart grid charging infrastructure, that is for smart charging, we definitely need to actually look at that as well to considering the advantages that we can exploit from these EVs. Battery swapping station is an very important actually factor that we need to actually talk about. Government has recently allowed the sale of EVs without batteries, which indirectly is means that battery swapping stations would actually be quite useful here. Also, they provide a good alternative for fast charging as well, or fast replacement of the batteries, where you don't need to queue up in the stations. But there are some issues that we have noticed and observed, which are mentioned here. For example, GST subsidy for EVs which come with EV electric vehicle is 5%, whereas if you are buying it from other sources through the swapping stations, it is 18%. FAME 2 subsidies, how to claim subsidies in case you are buying battery from the other supplier. The standardization of battery, which battery is going to fit, how the swapping station will take care of that. Who is going to own the battery in the swapping mode? That is the other issue. Then the warranty. We have had several stakeholder consultations with OEMs also. They have a concern about the warranty. They say that no, we are not going to actually honor the warranty in this particular case. It's not going to help us. So there are warranty issues that need to be taken into account. In fact, some of the OEMs said that it's not only battery warranty. We also have a concern on warranty of some of the auxiliary equipment in the battery required by the battery in the EV, which is anyway provided by the EV maker. They have concern even on the warranty of that. They have different side of concern that needs to be taken into account. Yes, so accountability issues as safety of EVs would be one of the prime concern as well. Looking at the other aspect of this, advantage that we can exploit from these underlying storage of the batteries. This is this bidirectional feature of the charging stations that would be there down the line. That's likely to be there down the line. Some of the countries, EV-rich countries, have been already, quite actively working in this space. For example, Denmark, California, and some other countries have been actually, utilizing it and taking the benefit of this bidirectional feature of the chargers, EV charging space, and it can be, very beneficial to the grid, to the distribution system operator, and other stakeholders who would be in this space. But having said that, we need a lot of enablers in India, a lot of other issues to be taken into account to have this vehicle to grid or vehicle to X, other vehicle to let us say home, vehicle to vehicle, or other these support services from the vehicles in terms of grid support, be it renewable energy integration or other support services to the grid, which needs to be taken into account, and we need to be more futuristic, in our opinion, in Indian scenario, so that we can be better prepared and are in a position to take the advantage of this large storage that EVs are providing. For example, there are studies which say more than 90% of the time the private EV, the battery storage in EV vehicle is lying underutilized. So why not utilize that unutilized energy storage in this? Of course, there are concerns of the battery health and all that. That is there. But yes, there are studies that it's not always a serious issue when it comes to the support services it provides to the grid. So standards and protocols for communication as well as EV chargers are important actually aspects of the EV charging infrastructure that need to be taken into account as quickly as possible, keeping the futuristic scenarios in mind where these distribution system operators could actually take different support services, or grid can take different support services from this. Not only support services can also manage the load of EVs. Smart charging is very important aspect that is being given strong focus in different countries. Some countries, for example, UK has come with draft policy for smart charging. Other countries have already different regulations and policy enablers there in place for smart charging, because smart charging has a lot of potential to help this uptake of EVs, not only from EV side but also from a lot of additional support services for the grid. For example, ancillary services which are there. California, Denmark, and some other countries are already open to have these ancillary services from EVs, because the ancillary services are normally technology agnostic, so they can participate in these ancillary service support services. This is an example
Professor
of
Zakir. Professor
yes,
Zakir,
please.
sorry to interrupt, sir. Sahana here. In the interest of time, it would be nice if you could wrap up.
Sure. Yeah, I'm almost close to the end. Sorry for the delay here. So
sure.
Yes, so renewable energy integration. Yeah, there are a lot of opportunities in renewable energy integration where we can utilize this EV space for enabling more renewable energy integration. So this is the preliminary update that we are presenting today of the study that we have been doing, and there is a lot more to come in coming months. These are tentative ones that we have put here. They may change here and there. So we have a series of reports, as mentioned earlier, which are coming. We have, so particularly this gap analysis and recommendations would be there that we are working on. Status quo of these electric vehicles in India, charging infrastructure in India, and other study outcomes that would be there will be, some of them, as have been mentioned, will be made most of them will be made public, and we'll be glad to have your inputs, feedback, and would be happy to disseminate the results through these reports once they are ready. I'll try to quickly wind up. I think most of this stuff has been already mentioned during the presentation that I made here. There is a relatively more focus on this two-wheeler, three-wheeler charging infrastructure in India for obvious reason, because we have more number of two-wheelers and three-wheelers. But having said that, four-wheeler segment needs a reasonable focus as well, because down the line four-wheelers are expected to be also in a good share in the market. Not only we should not only see in terms of numbers, we should also see in terms of the energy and the power that they have under the battery that they are going to host. We have a battery capacity of, as of now, 40 kilowatt hour for a four-wheeler, which is equivalent to around 20 two-wheelers battery. So therefore, it need not to be seen only in terms of numbers. We have to see in terms of the energy that is underlying under each vehicle segment, and the power that they can that would they be drawing from the grid and can have a potential to support the grid as well. Battery swapping that I already mentioned, I think we can skip this. Public charging stations need to be, more focus need to be given to the fast charging, but there need to be other issues that should be addressed first as well, or in parallel, I would say as well. But we need to give, in our opinion, more focus for the fast charging in the public charging space. Grid infrastructure arrangement, smart charging, I think is also important in the context of futuristic scenarios. With this, I would like to conclude this presentation. Thank you so much, and sorry for overshooting this time. Over to you, Sharma.
Thank you, Professor Zakir. Thank you for presenting the various gaps in the deployment of EV charging infrastructure in the Indian EV ecosystem. Unfortunately, due to the constraint in time, we would not be able to undertake the Q&A session. However, I assure you that we have made a note of all the questions that you all have, and we will get back to your questions in response in the written format. And as Professor Zakir already mentioned, that we are in the middle of the study that we are undertaking currently, and your questions will surely help us in strengthening the report that we are currently working on, and it will help us in addressing the various issues that you people have brought up through your questions. And also, I would like to add, since many have been asking, that we will be sharing the presentations with all the participants through online sources. And so, skipping the Q&A session, we will directly move on to the panel discussion. The panel discussion is on Indian EV charging infrastructure and the way forward. The moderator for the session would be Professor Zakir from IIT Bombay itself, And the other members of the panel would include Mr. Pankaj Batra. He's the project director of SARI EI program in Irade and ex-chairperson and member planning at CEA. Next, we have Mr. Avdesh Jha. He is the vice president of Photon Charge and Drive India Private Limited. Next, we have Dr. G. Ganesh Das. He's head strategy, business excellence and collaboration at Tata Power Delhi Distribution Limited. Plus, we also have Professor Pablo Frias from IIT Camelus, Spain. And lastly, we have Professor Martin Braun from Fraunhofer IEE and University of Kassel, Germany. I would like to welcome you all. Thank you for being a part of this panel. And I would request everyone to come on camera, all the panelists to come on camera and put yourself off mute. Rest the participants, I would again request you all to be on mute and be a part of this panel discussion. Over to you, Professor Zakir.
Thank you, Shovan, for introducing the panelists here. Thank you very much to all the panelists for being here with us on this very important topic that we see is very interesting and very relevant to the Indian EV ecosystem. So I'll start with. I think you have heard the presentations and you are well aware of different developments in EV charging space in India. So therefore, I would like to start with 1 minute or your opinion of, restrict it please to 1 minute, your opinion on what are the major challenges that you see in uptake of EV charging infrastructure in Indian EV ecosystem. So maybe I'll start with Mr. Pankaj Batra.
Okay, thank you, Zakir. I think there's already been a good policy push, so the policy is in place. I think where it's lacking is the regulation, which is normally to be implemented by the states. So regulation is a thing which will talk about the price at which the state distribution companies sell electricity to charging stations, and as far as what charging stations will charge the vehicles is if there is a subsidy given to the charging station, then they can dictate on the ultimate price. But otherwise, it can be done through competitive basis. But yes, the regulations of what the charge the state distribution company would charge to the charging stations is one, as well as other regulations with respect to which would talk about a lot of issues about on both sides, whether it includes smart charging stations, which means fluctuating the rate of charging depending on availability of power in the grid, and safety and many other things. So it's basically the regulations which are lacking really, because unless you have the regulations, people may not go ahead. Right, that's it. Thanks.
Thanks. So I would now move to Dr. Ganesh. You come from one of the key stakeholders in EV charging space. So it will be really nice to have your opinion on this.
Thank you, Zakir, and good morning, good afternoon to all, and good evening wherever you are. Actually, if you look at India per se, we have not been great with respect to our planning. Somewhere, if you look at our urban development, we have somewhere we failed. Our planning is little, and this is not because of there is any bad intention, because the pressure comes from different quarters. Somebody from a particular industry pushes, the political system pushes, and there could be some kind of syndicate which pushes for something. So typically, what happens is we miss looking at the things in a very holistic manner. So instead of looking at a holistic manner, we are focused on the individual priorities, short-term perspective a little bit more than the kind of a medium term. I will not even use the word long-term. So we miss out on the planning. So that becomes very critical for doing this kind of a thing. And then if you look at the regulation, what Pankaj was mentioning, the regulations are, state driven, and then central largely advises. So there is always a challenge when central tries to push something and the states have their own priorities for doing it. So that is where one of the gap is. And if you look at somewhere, we have really need to be very careful. And there is an opportunity through this electric vehicle charging infrastructure development to really kind of set off that shortcoming which we had seen in the planning stage. And essentially, we have to now focus on the process and how do we really manage the things. And we had great presentations to talk about that, economics and the cost, and how do we really look at a stacked up benefits of electric vehicle deployment rather than looking at individually. Like that, for instance, how does electric vehicle is going to help the environment, going to help us to manage the electric load in a very steady manner? How does it is going to help at kind of managing the network in a better manner? How does it really help us to kind of optimize our generating things like that? I think a holistic framework is more important here. Thank you.
Thank you, Dr. Ganesh, for pointing to some important issues here. So Martin, thanks for joining us, taking your time early morning. So what's your opinion on this?
Yeah, hello everybody. Thanks a lot for inviting and being able to discuss that. I think, Zakir, you already gave a really brilliant presentation of the status in India about all these issues. So it's really comprehensive, and I'd like to underline what Ganesh was just mentioning. We need a comprehensive approach. So we have so many development threats that are ongoing, and different companies going for business cases and doing hands-on fast activities to be first mover and so on. And I think what is somehow needed is to harmonize those different activity threats. Even if there are things popping up, there needs to be a strategy behind that. And of course, some activities need some time to evolve. And I'd like to focus on one point due to my background, which is the grid codes, actually. You also mentioned it in your presentation shortly. I think this is important if you are going to a rollout of charging infrastructure, that you from the first step on, you have a clear grid code that allows afterwards to integrate those charging points actively also in any future grid upgradation, reinforcement, or smart grid activities. And I think this is something I'd like to point out as a starting point.
Thank you, Martin, for providing these important opinions. I'll move to Mr. Avadesh. You come from charging infrastructure, CPU side, right, other side. So you definitely bring in a different perspective, in and out from that perspective. So please share your opinion on it.
Yeah, thanks, Zakir. So your question was regarding the uptake of the public charging infrastructure. So clearly, the
major challenges, yeah.
Yes. So uptake means that first the consumer has to be there, then only the uptake will come. So essentially, how do we incentivize the consumer to buy the electric vehicle? And that is important. So there, I see a mismatch, which has been reflected in your presentation also in the first slide itself, that the communication from the government side, I believe, is slightly confusing. Because on the demand side, you are saying that you will be promoting two-wheelers and three-wheelers. And on the four-wheeler side, you are saying that you will be allocating the 1,000 crores charging infrastructure. But then you will be creating an infrastructure, but you are not promoting those vehicles. And remember that, out of the 3 million cars which is sold annually, 95% is still on the individual owners, right? And if you took the economic value of these 3 million cars sold, is almost as equal to as 83% of the two-wheelers cars economic value, So in terms of the GDP contribution, in terms of the labor employment, all those things, the car OEMs are contributing equally, like the two-wheelers. But then you are saying a message to the four-wheeler OEM, I don't care for you. You can continue with the ICE vehicle. I don't mind, but I will put the charging infrastructure here and there. So this is a confusing, I would say, and I believe that India, which is a youngest nation in the world, in terms of the demography, I would say, in that the people are aspirational. The purchasing power capacity is increasing. So if the people are aspiring, people are not aspiring for buying two-wheeler two-wheeler vehicles. People are buying for four-wheeler cars. Now, when the new technology is there, why don't you promote? So I feel that the FAME 2 requires to be modified and make the vehicle agnostic, irrespective of, you have a budget of 10,000 crore, fine. But within that 10,000 crore, if the OEMs brings a good product, and if the individual consumer is willing to buy, they should let them also get the benefit within the same boundary conditions. If the two-wheelers are bringing the good product, they are taking it perfectly fine. Don't bring it to 1 million, 500,000. The moment 10,000 crore is exhausted, either you extend it or you close it. So I think I feel that once the consumer side aspect is thought through, and as Ganesh rightly said, unless you have a holistic view, you can't have a compartmentalized view. Government cannot be seen to be promoted one segment. Government should be neutral, for the two-wheeler, three-wheelers, four-wheeler, buses, trucks, everything. Government should be neutral. So I think that is very, very important. And then only, we can create the charging infrastructure. But unless the consumer brings the, buys the car, and unless you enables them to buy the car, buy a good product of the vehicles, and good product of the vehicles will come when OEMs are given the signals that, look, you are free to do this, these innovations. Then only this could happen. Otherwise, this struggle will continue.
Thanks, Mr. Jha, for raising very important points. You brought in this economic side as well. Coming from the technical side, I was talking only about energy when I was comparing four-wheeler and two-wheeler, and you brought in one more important point about this economy side. So quickly, Pablo, what is your take on this when it comes to, you have a now reasonable understanding of Indian EV ecosystem, and you come from the European side. So what is your opinion on this?
Yes, so basically try not to repeat the same errors that we are doing right now. So these errors are, already mentioned. One is government. There should be what we call vertical integration of strategies. Vertical means from the very top government down to the end municipality. Everything should be aligned. If not, decision making is down there. Money is up there. So we should coordinate these things. However, this is not only what we need in government. We need also horizontal thing, because in any government, both upwards and downwards, we have environmental thing, but we have the industry and we have the tax collection. So all of them will be winning and will be losing. So we should to integrate all these, let's say, ideas at the same time. That's one important thing, vertical, horizontal coordination. Second thing, and that's something that was previously mentioned, when we think about electric mobility is just a small piece of sustainable mobility. And sustainable mobility is about efficient mobility, it's about low emission mobility, and it's about safe mobility. So it is not four-wheelers, maybe it is not only two-wheelers or three-wheelers, it is also about public transportation. So going back to Ganesh, we need to have a holistic, and please don't commit exactly the same errors that we are doing in Europe. We are still missing many integration of these things.
Thanks, Pablo. A very important point. Let us not try to repeat the mistakes that other EV-rich countries have done, and instead we learn from their journey and take it on from there. So my next follow-up question or related question is to Dr. Ganesh. Based on our study and based on our stakeholder consultation we have been doing across the spectrum of the stakeholders in EV charging infrastructure, this is a question considering you represent the DISCOMs. there is an impression among a reasonable number of players that discoms need to do more proactive role in enabling this charging infrastructure integration with the grid. Two things I can specify here. One is, fast clearance of this EV charging station if some private player or any other player is coming to the given discom. Second is this upgradation, which of course has the other side, as I mentioned. You would definitely come from bring another perspective, discom perspective in this upgradation of the distribution network wherever required, particularly in these charging stations, fast charging stations. What is your side on, what is your opinion or point of view on this from discom side, representing discom? So it's not very specific to Tata Power here.
So Zakir, the thing is, as I was mentioning, you don't need anybody to sell the concept of EV in India. I think if you look at across the ecosystem, everybody accepts that EV is something which is going to be very useful. It's going to stay. And I was mentioning that what is more important here is the process part. How do you really look at the process of going about doing things? And if you look at the Delhi, tender which has come out, we were part of the committee, and there are two dimensions here. One is the infrastructure upgradation, which the discom will do, but the infrastructure, the discoms were not allowed to kind of book the charging infrastructure into the ARR. There was, of course, some subsidies, etc., given on that. The fact is, that could have been also one option. But the Delhi government did not choose to do that. It kept it that open. But at the same time, told the discoms that you are also free to participate in this and set up the infrastructure, which will be outside your ARR. That is one model of, kind of having a kind of inclusiveness into the process of doing that. But another point is, what is, if you look at our new connection management process, there is a rule defined by the DRC that how many days you can give a connection for a new customers. And I'm just taking an example. If there is a domestic customer, we are given, say, 1 day, 2 day, 3 day, 15 days as the different discom is concerned. So there is a kind of a space given by the discom for whenever there is a new load added to the grid. There is a process which has been followed. When we are going to look at EV, you are not going to give that flexibility. Somebody is going to come in who may not be your customer, so he's going to just plug in into the grid. I would like to give an example of a fantastic point which Professor Quwei had made, that increase in 1 to 2 kilowatt load of the household in Norway has lead to 10% increased load in the transformer. It's a very valid point. So what we are trying to look at is everybody sees that one charging infrastructure, but it is going to kind of aggregate onto a distribution transformer, and there are certain rules and regulations and the challenges for maintaining the transformer. So you have to make sure that that particular area has to be, that particular transformer has the flexibility, and how do we really move the load, etc. on that. Then another point which has been made in the presentation is you are looking at a passive, static, active, and dynamic charging management. That part is also extremely important. So how do you really manage all those things? So what is more important is to look at not setting up the charging infrastructure, but how are you going to facilitate this infrastructure to manage the load, which is in kind of synchronized with the grid. That point is extremely important to look at that. And the third point, which is extremely important, is the cost. Right now, the tariff which has been given by the Delhi government here, which is lower than the average buying price, and that is not a sustainable model. Every subsidy is not going to drive the business. The real business is going to be driven by when it is going to be sustainable, and it is possible to do that. Another point which has been made by the presenters, and I think with Martin also we have had few discussion on that. So how do we really define a very interesting time of use tariff at different, looking at the household, looking at the residential customer, industrial, and the EV tariff? And can we give a benefit of, the dream for any utility is to have a flat, load peak. In the sense, a flat load where you are not having a crust and trough of supply and demand all the time. That is what we are looking at. Can we move closer to this line, kind of a straight line, and then work around all the tariff and work around and the application in such a fashion, and we use EV for kind of providing that flexibility. And you also made in your presentation the point of demand response, the beyond the meter optimization, etc. So how do we really work around this? And let me tell you, it is not going to take a very long time to do that. Once we have this process set in place, the point Pankaj was making on the regulations in place, and then kind of create a sandbox and look at a very small area to see that how this can work, and it will work, because you have got today, if you see the utilities, we have got our flexibility, we have got an advanced distribution management system in the grid, we have got a sensing system in the grid, and then we have got systems to look at the power quality as we are managing the coming of the electric vehicle, charging, and kind of going off the solar input into the grid. So there are a lot of options to look at that. The whole idea is we should be we should learn from the way Germans do. Martin is sitting here. We should learn the way Japanese do. We have to spend a lot of time on planning and defining the process. That is extremely important. I'll stop here. Maybe we can take the discussion further. Yeah.
Thanks. Yeah. Thanks a lot. So we are, as per the schedule, hitting the time here, but because of technical glitches and other things, we got delayed. So my request to organizers, with the due permission from panelists, is can we extend it by 10 more minutes?
Yes, please. Yes, please continue.
Yes, sir. Please.
Thank you so much. So moving on to Pablo, on this role of discoms that they can play in active role that they can play in this EV charging infrastructure uptake or adoption. What is your perspective considering the developments in Europe, in these EV-rich countries on this? What active role discoms can play, which can help in more, seamless adoption of the charging infrastructure?
Yeah. So basically in Europe, what we saw, in Europe we have difference between the distribution company and the retailer. So basically the retailer, they want to have more electrified systems, both the industry, both mobility. That's okay. So they are pushing for that. On the other side, you have the distribution company that they are expected to face some constraints in the operation. They are expected. However, real situation did not face this kind of, let's say, congestions. We did face congestions with the distributed generation, but not really with the electric mobility. Why? Because we anticipate and retailers begin to work on these time of use systems. That's one thing. The second thing is that we should also, and that's part of the government. We should not 100% rely in the energy systems to push forward electromobility. No. The thing is that we need to create a competitive playing field so anybody can integrate. One of the things that for instance, we are taking in many European countries is that it is not only the energy company nowadays moving towards electromobility. It's the traditional fuel companies, it's the supermarkets, we have plenty of competitors. And these really, let's say, starts the thing. And this new competition really makes the government move ahead and so on and so forth. So this is in a nutshell what we have in our experience.
Yeah, thanks, Pablo. So I'll move to another question, which I'll start with from Mr. Jha. So the swapping stations that we have been talking about are being foreseen as important supplementary options for this charging infrastructure. So what is your opinion on this swapping station in general and in the context of Indian charging infrastructure ecosystem?
Yeah, so we personally believe that in Indian market, swapping station, battery swapping is going to play an important role because we have a different vehicle segments. Unlike Europe and other OECD countries where predominantly the four-wheelers are there, in India we have two-wheelers and three-wheeler segments where the battery weight and the load requirement is quite less, which can be managed through the battery swapping. Because the driver for the battery swapping was primarily the cost of the battery or the vehicle itself. Second was the turnaround time, and third obviously was the charging time. So clearly this suits quite well with the two-wheelers and three-wheelers where you have if you take out the cost of the battery, obviously the vehicle cost initially comes down. In the long term, when the battery technology improves, then the cost, doesn't matter. The only thing which will matter is the charge time, the charging time. And that will remain important for two-wheelers and three-wheelers fleet, but not maybe for the individual owner who owns the two-wheelers vehicles. So we believe that for personal mobility, battery swapping may not be the, selling in Indian market, but for the fleet, the battery swapping on two-wheelers and three-wheelers might, will be a good proposition. But on four-wheeler side, I believe on the car segment, the battery swapping in the world has tested it with a better place, as well as the Tesla also had demonstrated, but then they have currently shelved that project. I don't believe that the four-wheeler OEMs will, do away with their control on the battery, because that's the differentiating factor for giving the different kind of an expectations to the individual customer. So that will be the challenge in the four-wheeler segment. Besides, even in the three-wheelers and segment, I would say, unless the government comes out with a standard form factor and the standardization of the battery, it will be very difficult for energy operator to manage different set of batteries for different vehicles. Because current regulation which the government has come out, it says that you can separately sell the battery and the vehicle, but the battery still attracts 18% GST, whereas the vehicle attracts 5% GST. One manufacturer's car with the two-wheelers might not be suitable for the battery which the the energy operators are holding it. So I think these are still areas which requires to be worked upon, and if that is stitched well, then the battery swapping in the three-wheeler fleet segment can do well.
Thanks, Mr. Jha, for your very interesting observations here on swapping stations. So my next question is to Mr. Pankaj. You coming from the power sector, having a lot of experience, understanding of the power system, power sector and power system, particularly from the holistic point of view. How do you see, when it comes from the grid side, how do you see the values of the underlying storage, apart from obvious, of course, ancillary systems and other things, in the Indian context, considering Indian electricity market, Indian grid? How do you see holistically the most important opportunities that we can tap from this underlying storage of this e-mobility sector?
Okay. So, renewables, the thrust to renewables in India and electric vehicles is actually complementary because on one hand, you have intermittent supply, which is solar and wind, where it can go up and down. On the other hand, if you have smart chargers, you can have intermittent demand based on availability of power in the grid. So it's been very good for these both to be there, provided you enable regulations. So the CRC has come out with the regulations on ancillary services, which also includes demand response. So now this is an opportunity for people with demand response also to take part. Now it of course develop over time of a number of other things, but it's a very good complementary mechanism for these two to be there, and the Indian government has given thrust to both of these. So I think it'll be very good. It'll reduce the requirement of supply side ancillary services if you have demand side ancillary services which are there. And there are I know that there are some. I mean, it's mostly in the pilot stage globally also, but there are standards ISO 15118 which are for vehicle to grid. So of course, there's an issue about the life of the battery, because a battery is guaranteed by the manufacturer, but it depends on the number of cycles and also the chronological life. It depends on both. But I think it will come out, at a later stage of how to manage that. But as far as charging, you can increase or decrease the rate of charging by a smart charger. At least to that extent, you can increase or decrease the demand of electric vehicles. So that definitely is there. If the battery gets injected back to the grid, that's another issue. But you can at least change the rate of charging, which means you increase it when there's high power in the grid and you decrease it. I think it offers a very good opportunity for demand response from electric vehicles. And my preference would be that you have more of slow charging, and at a time when there is less demand on the grid. That means when people park their vehicles when they come back from work and it's the vehicles are lying idle in the night. That's the time you have the least demand. But that's the time when you can generate demand by charging the vehicles and at a slow rate. So there, the more it is connected to the grid, the more opportunities it has for demand response. If it is fast charging, if it's for a short time, then it's a lesser time when it's connected to the grid. So I think there is it's basically optimization of the whole system. As of course a number of people pointed out, it's you have to look at it holistically, but it's all to be done through a plan, and all this plan can be carried out by putting the time of use tariff of charging stations depending on availability of power. So I think that there's a huge opportunity there. Yeah, okay,
thanks. And thank you for bringing in this perspective. And of course, there are in Indian context the issues as far as, because the characteristics and the nature of these resources is different than, let us say, renewable energy plants which are connected directly to the grid, and this underlying storage will be connected to the distribution system, and the role of the distribution system operator comes here much more active than the renewable energy generators, and let us say through open access and all that issues related to metering, billing, all those come into picture in Indian context, which also need to be taken into account. Thanks for giving these important.
Just one more point. This is not only for ancillary services from the point of grid stability, but also from the point of view of utilization of the distribution system. Because smart chargers will also increase or decrease the rate of charging depending on if the transformer is getting overloaded, and to balance the charge among number of vehicles. So it's optimization basically, which smart chargers would provide. Thanks.
Yeah. So that brings to me, probably we have to stop it here. The last question, which is relevant to this, is smart charging we know of, and what should be the focus in Indian EV ecosystem as far as the smart charging is concerned. So I'll probably go to Martin because he has understanding of smart charging in European context. So Martin, what is your opinion in adoption of this smart charging in Indian EV ecosystem? How in your opinion should be the focus, or to what extent should be the focus for smart charging in the Indian EV ecosystem, where we are still relatively at infancy stage, but that also gives us an opportunity to plan better our this mobility sector when it comes to integrating with the grid.
Yeah, I think we have to see one point, which is uncertainty. I think we are in a situation where we expect a development of EV, but we don't know exactly where, when, what, and how things evolve. That means we need mechanisms to deal with this uncertainty, and smart charging is one of these mechanisms. Especially with regard also toward the discoms in order to deal with these upcoming installation of charging points and EV charging, because I think it's extremely difficult to understand what is really the customer's behavior with the charging, where they charge, when the when they charge in parallel or if it's distributed along the day. I think these are a lot of uncertainties, and I would recommend to on the one, well, mainly on 3 points. One is to clarify on the grid codes of charging stations, especially for the larger power stations, to really clarify how they should behave, looking also at DER requests, so PV installations and so on. On the one hand, with this grid code, you should also have the opportunity as a second point to monitor, so to be able to get the measurement information, how it is developing. So if we have certain peaks that need to be considered or not. So we need to have this information, this transparency, what is happening. And the third point is if we have defined the grid codes, and discoms could also access and curtail to a certain degree the power demand of the charging stations. In case we have those peaks, there is a flexibility in order to reduce the criticality of grid reinforcements, so it could be delayed, and you can deal with this uncertainty I was mentioning. And I think this is important to have the grid codes, the monitoring information, and the possibility to control in order to really be under a certain governance and guidance through this uncertainty uptake of the evolvement of electrical vehicles, not only in India. I think that is a topic throughout the world, which is important.
Thanks, Martin. Even though we have several interesting things to discuss here, it was going very, very nice discussion that we had. It was going in a very interesting way, and there were several very, very important points that I would have loved to discuss here, because we have very eminent panelists here who come from different dimensions of this EV charging infrastructure. But I'm really sorry that because of this time that we have overshoot by 15-20 minutes, I would have to stop here. And with this, I would like to thank all the panelists for their time that they spared to come here and give their inputs on these very important, relevant issues related to the EV charging infrastructure. Thank you so much for your valuable inputs and the suggestions that you provided on these very important issues. Thank you very much. Over to you, Sharma.
Thank you, Zakir.
Thank you, Professor Zakir. Thank you, Professor Zakir. Thank you, everyone. I would again like to thank Professor Zakir, Mr. Pankaj Batra, Mr. Avdesh Jha, Dr. G. Ganesh Das, Professor Pablo Frias, and Professor Martin Braun for the amazing panel discussion. I'm sure we lost track of time and we overshoot, but it was seriously worth it. And thank you, everyone, for your time. Lastly, I would like to welcome Dr. Indradeep Mitra, Team Leader of E-Mobility Indo-German Energy Program, as well as Country Coordinator for the NDC-TIA India component in GIZ India. Dr. Indradeep Mitra, to provide his vote of thanks.
Thank you, Sushavan. Am I audible?
Yes, sir, you are audible.
Thank you. So, good afternoon from Delhi here. It was actually sad to cut short the lively panel discussion. However, we have some time constraint. We cannot let it continue. It would have easily continued over 1 more hour or so, it seems. I have my now duty to provide the vote of thanks, and I, on behalf of GIZ and the entire NDC-TIA project partners, extend heartfelt gratitude to all of the speakers and the participants for gracing the knowledge and wisdom today on the topic of charging infrastructure and its integration with the electricity grid. I'd like to extend our sincere thanks to BMU for funding our NDC-TIA project, and to the organizers of the TCC, that means the Transport and Climate Change Week, under which our event is organized. Hope all of you are taking part in this week-long activity spread across the globe. Even actually at 12:45, there will be a very nice event where from India, Niti Aayog is also participating. I would like to express gratitude to Mr. Madhav Sharma from Niti Aayog for his insightful speech. Niti Aayog has been a genuine implementation partner for our NDCTIA project, and it's continued to support us in every aspect of the project. We are honored to have Professor Rangan Banerjee with us today. His team with Professor Zakir H and a pool of researchers in IIT Bombay is putting tremendous effort for this project, focusing on charging infrastructure. Our deep sense of appreciation to Professor Pablo Frias, Professor Quwei, Professor Martin Brown for bringing international perspectives to this event. Many thanks to Florence School of Regulation, who will bring India as well as international regulatory aspects in this study. We are elated to have with us a galaxy of learned specialists and panelists from India and abroad who grace the event by their thoughtful opinions. Sincere thanks to our NDCTIA project working group partners for their feedback and constant encouragement for this ongoing study. I would like to thank every participant who marked the presence in this event and actually waiting for this event to have a successful closure, overshooting the time. Last but not the least, a big thanks for my own team members for the efforts they are putting for this event as well as for the entire study. We have made note of all your questions and we'll get back with our responses in written form. We are in the middle of our study, as Professor Zakir already shown, that we will eventually release 4 reports out of the study, a few 2-3 months more to go. As a closing remark, I would like to mention that EV charging infrastructure must be addressed holistically, and the potential for sector coupling between transport and energy should be harnessed through various opportunities in the electricity grid ecosystem. Thank you very much once again. Have a nice day.
Thank you.
Bye. Thank you, everyone. Thank you for your presence.
Yep. Thank you.
Thank you.
Thanks a lot.